Let's talk about linear transformer. Here is one example. You can see here is a transformer have a primary side and a secondary side. Okay, here is a secondary side. And we want to find the voltage V2 here. Okay, so look at the primary side, the left-hand side. So we have a cosine voltage connected to the circuit. Okay, if you forgot about the right-hand side and forgot about the dots, then this is just a cosine voltage source connected with a resistor and inductor. We can solve the circuit. We can find this current. Right? We bring everything into a phasor domain. Okay, inductor, resistor is still resistor. Inductor become j omega L. Okay, omega is 10 here. So just 10 over 1 plus j 10. Then we can find the complex form I1. Okay, but this is not just a simple circuit. This is a transformer. That means this inductor and this inductor are coupled. There is a common core there. Okay, so when you connect this changing voltage source will cause a changing current I1 is in cosine form as sinusoidal form as well, and this changing current will actually cause a voltage, induce a voltage on the second side or a secondary side. Okay, and this voltage will go through all this impedance, will generate this I2. They are affecting each other. So there will be two loop or two mesh. We're gonna use the mesh method to build the voltage relationship for the loop number 1 and loop number 2. Okay, for this one we got this I1, we got this I2. We bring this one into phasor domain. So if we can solve this I1 and I2, then we can find the current. Okay, so there will be two kinds of voltage. The first one is called a self-induced, because this current flow through this inductor will be I1 multiplied J10. That will be the voltage caused on this one. It's called self-induced. Is have another voltage source called a mutual-induced. Okay, it's caused by I2. So the first voltage here is caused by I1, but this voltage source is caused by I2, called mutual induction voltage. All right, so let's review this one. Probably you forgot about that. So let's go back to the very beginning here. And this part is actually from chapter 6.4 of your textbook. Okay, so you can see that the V2 here is open circuit. There are no current in the secondary side, but there is a changing current in the primary side. Okay, so it will induce voltage V2 or generate a voltage V2 at the secondary side is equal to M di dt, di1 dt. Okay, so you can see it has to be a changing current. If the current is constant, the derivative of that is 0, so there will be no voltage here. So if you have a changing current, such as a sinusoidal current, you certainly will have a V2 generated in the secondary side. Same thing for V1's open circuits. There's no current because it's not a complete circuit, but the changing I2 will generate a I1. The changing I2 will generate a V1. Okay, this polarity of the voltage will follow the dot convention. Okay, let's review dot convention as well. So if the current enter dots of one coil, produce a positive sign voltage reference at the dot terminal at another side. Okay, see here I1 is actually go into, which is enter the dot. Okay, this one is enter the dot. This one is leaving the dots because the dots is down here. This I1 is leaving the dots as well. Okay, so this one, the first one here, is entering the dots. So this dots will have a positive sign. So I gave a positive reference like this. So this voltage got a positive. Okay, this current goes to the dots. So it will induce a voltage at a positive sign at here. Okay, as you can see, this one is just opposite of the reference I give here. So this V2 got a minus sign here. All right. Another one is this one is leaving, not entering, so leaving the dots. So this one will get a negative sign. Okay. This is a contradiction to the reference I preset. So this V2 got a negative sign. Okay. And this one's leaving as well. And so this one should be a negative. This should be a positive. So it's just follow this reference I gave here. So it's a positive. All right. So you can see that I always have the positive reference on the top. So this is actually the way Kenny used in his lecture. So if you do that, then the voltage sometimes have positive value, sometimes have a negative value. Okay, I'm using a little bit different way I'm going to show you later, but these two methods give you the same, exactly the same result. Okay, after we know the dot convention, I'm going to skip this example. We're going to look at this circuit as well. You can see in the previous example, okay, only one side have a current. Only one side have a current. This side have current, and in this case, the secondary have a current. Okay, so if one side have a current, it will induce a mutual inducted voltage on one side. On the other side, okay, I2 will cause voltage on the primary side, I1 will cause voltage on the secondary side. Okay, so in this case, both sides have current, so we'll have two voltage induced. Okay, when we analyze those circuits, you gotta do the self-induction voltage and a mutual induction voltage separately. Self-induction voltage, as I mentioned, is caused by I1 flow through this L1, the inductor number 1. Okay, you can think inductor number 1 is a impedance. You can think that this is a ZL1. Okay, there is a current I1 flow through it, so the voltage drop on this impedance is I1 multiplied with ZL1. ZL1 is the J omega L1. Okay, so that's the self-induction voltage. And this voltage follow passive sign convention. Okay, that means the current flow as voltage drop. So this is a voltage drop. I always have this sign because it's a voltage drop. Okay, another one is the mutual induction one. Just the red one I draw here. Okay, this caused by I2. I2 go inside of or enter these dots. So this dots will have a positive sign. So I will have a positive value here. Okay, so this is, if you look at the direction of the current, this is a voltage drop, and voltage rise. So if you complete the loop, V1 is a voltage rise because current go that way. Okay, same thing if you, then let's draw this circuits. Draw this equation for loop number 1. So this is loop number 1. Okay, so V1 is voltage rise and gonna equals to voltage drop, which is L1 di dt is self-induced voltage plus M di dt. Okay, it's also equals to I1 J omega L1 plus a I2 J omega M. Okay, so if you do the Laplace transform of these two, you can get exactly the same result here. Okay, for the second loop, let's do that again. So we have a voltage, self-induced voltage, which is I2 di dt L2, okay, or capital I2 multiplied j omega L2. Okay, this is a voltage drop. This one induced by I1. I1 going to the dots, so this dot's got a positive. This is called a dot convention. Okay, voltage drop, and V2 is voltage rise from bottom up. Okay, so V2 is on one side, the other voltage on the other side. Okay, let's look at another one. So in this case, we have the current entering this dots. So in the other side, in the secondary side, we have a positive sign, same as this dots. Okay, but for I2 is actually leaving this dots. So this dot's got a negative sign like this. Okay, I use this sign convention for dot convention, so I can keep all the values positive. All right. Again, for Kenny's one, Kenny always put a positive on top. So in this case, if you put a, let me write it here. So if you put a positive sign up, a negative sign down here, you will get a negative m di2 dt. Okay, that gave you exactly the same thing. All right, it's just convention. Right, let's build this two loop voltage. So following the current, so this current goes, first the current goes down through this one. So voltage drop and voltage rise. So this is a voltage drop and this is a voltage rise from negative to positive. Okay, and this is a voltage drop from positive to negative. All right, these signs, this black inked colored sign is predefined. Okay, and so this is a voltage drop. Okay, and equal to 0. For the right hand side, the secondary side, you can see the current goes this way. Okay, from left to right and go down. So this is voltage drop. Okay, that's voltage drop, voltage rise, that's voltage rise, and that's voltage drop. Okay, that's voltage drop. So you got this one. Plus together equal to 0. Then you can move these to one side and you can do a Laplace transform. You can see become a capital letters and this become j omega L. That's the impedance, that's the current, because this is self-induction induced is only related to I1. Okay, and there is a negative sign here. And let me shrink a little bit so you can see that there is another term which is this one. Okay, j omega m has to be very careful. This one's I2 because this is induced voltage caused by I2. All right, then you have another equation from V for the secondary side. And you can see that I1, I2 is the only unknown in some case. So we can solve I1, I2. All right. If we know this story, okay, we can solve this question from beginning. All right. So that's the voltage being given here. Then we bring everything into a phasor domain, so j omega L. So this is a j omega L as well. So this is a j 1000 because omega is 10. So you can see that let's write the sign as well. So this one is caused by I2. I2 is leaving this dots. So give that this dot a negative sign. Okay, so I1 is entering this dot. So this dot is a positive. Okay, and we can start to draw the equation. So if you look at this current direction, this is a voltage rise. This is a voltage drop, so it's on the other side. This is voltage drop as well, so 1 plus J10 I1, so these are voltage drop, and this is a voltage rise, negative to positive, right? So it's a negative, or you can put this one on the other side with 10 0 degree, right? I can write like this. For this one, you can see this is a voltage rise caused by I1, so I put a negative sign here. These are drop, so they are positive sign. These two, 1000J plus 400 multiplies I2. Okay, so you need to be very clear about how to write those two equations. Okay, you can see examples from the lecture notes and textbook as well. So make sure you are very comfortable write these two equations. So based on that two equation, two unknown, so you can solve I1 and I2. If you know I2, so V2, the voltage, it just equals to I2 multiplied with the resistance. Okay.